So in this video we will see how port 1 can be used as an input and output port, and this port 1 consisting of 8 IO port pins, so that can be configured as a output as well as input. Suppose if P1 as an output port means which will write CPU data to the external pin. Suppose if it is configured as an input port, it will read pin data, whatever data available at the pin, that data is copied into, that is placed into the CPU bus. So the P1 port, P1, P2 and P3 has got three main components. One is D latch. So this D latch is controlled by a signal write to latch signal. If it is 1, it will write the data into the D latch. And second important component is about your tri-state buffer. So according to the logic diagram, we have two tri-state buffer, TB1 and TB2. TB1 is controlled by read pin, so which is used to read the data present at the pin, and second one is TB2, which is controlled by read latch. When read latch is equal to 1 means it will read the value from the internal latch. And third component is output driver. So we have a M1 transistor. If gate is equal to 0 means it acts as a open switch, otherwise it acts as a closed switch. So port 1, port 2 and port 3, they have this particular logic diagram. So three main components. So the first component is the relatch component, and second one is the output driver, and third one is the upper and lower tri-state buffer. So next we will see how to output zeros and 1 to output pin P1.X. So let's assume this particular P1.X is configured as an output pin. So the case 1 to output 0. So for that, write the value to the D latch. So write 0 value to the D latch through the internal CPU bus. Then clock it so that the value is latched inside the D latch. So the output will be visible at Q and Q bar. Now Q will be 0 and Q bar will be 1. So this Q bar drives the output buffer. So this one on the Q bar switches on the transistor and it pulls down the pin to 0. So now the value 0 is available at P1.X. So your output is 0. So in this way we have to output the value from your port 1.x to the output pin. So next we will see how to output 1. So give 1 to the pin, let us place the value to the pin through internal CPU bus. So when we clock it, the output will be visible at Q and Q bar. So Q is equal to 1 and Q bar is equal to 0. So this puts the transistor in off state. So there is an internal pull-up load inside 8051 port 1 which will pull this pin to VCC, and output will be 1 now. So in this way we have to output the zeros and 1 to the output port pins. Suppose if the port 1 is configured as a input port, for that case how to read the value present at the P1.X. For input configuration, um, we have to move FF to port 1 by using the instruction move P1, #0FF. So using this instruction, we configure this P1 as an input port. Okay. So next you clock it and the date output will be visible. So Q becomes 1, Q bar becomes 0. Your transistor is turned off. Now your port pin is configured as an input pin. So the peripheral can send either 0 or 1. Okay, for example, if the value available at this pin is 1, okay, so this will go into the TB1, which is controlled by read pin value. So your read pin is 1, read latch 0, and write to latch is 1. And after that, you will get the pin value of on the internal data bus and the same value given to the D latch. So next, reading 0 at input pin. So same steps to be followed. First you have to configure P1 as an input port by moving FF to P1. After configuration, when we clock it, the output will be visible at Q and Q bar. Now Q is 1, Q bar is 0, your transistor is turned off. Now your port is configured as an input port. Now the data present at this point is 0. So this will go into the TB1 and placed on the internal CPU bus. At the same time, value is copied into the latch. Thank you.